Hey everyone, today we're going to look at the last part for electricity, which is Ohm's law. So now we're going to add the math part to circuits. So we talked already about current, resistance, and voltage, and the idea was that current is the amount of electricity moving through a circuit. Voltage is the electrical push, it's pushing the electricity through the circuit. And resistance is stopping electricity moving through the circuit. So these three different sort of parts that affect or describe how much electricity is moving through a circuit. Today, we'll add the equation that describes that, which is Ohm's law. We'll start with the idea for Ohm's law first, and it is kind of something we already talked about in the previous lesson, so this should be kind of a review, and I think you even have it written in this form in your notes. What Ohm's law basically says, if we keep it as simple as we can, it says that more voltage gives you more current. Remember, voltage is electrical push, and so if you push harder through the circuit, you end up with more current. It says that if you have more resistance, well, if you resist more, then there should be less current. So that's the idea that Ohm's law, what Ohm's law is trying to describe. Again, we talked about that already. But new for us is going to be the equation for this. We're going to add the math component as well. And what it does is it connects these three variables. The equation has sort of two different forms we'll talk about. It has I equals V divided by R, or V equals I times R. Alright, let's make sure we know what all of these things mean, and we'll start with the two more obvious ones. V stands for voltage, which we measure in volts. That's why it's called voltage. So V stands for the voltage, which we measure in volts. So wherever we see a V, if we're solving for it or if we're plugging in for it, that's going to be the voltage. R stands for resistance, which we measure in something called ohms. So R is, again, resistance is just the amount that it resists the circuit, and so this resistance value is the number that we would apply to that. It's measured in ohms, which you'll sometimes see written in this form. This is the Greek symbol omega. It's like an upside down horseshoe looking thing. And it's just shorthand for ohms. We don't abbreviate it with a 0 or with like an O for ohms because it looks like a 0 and that would change your number. So we use this Greek symbol. And last up is I, the only thing left. I stands for the electrical current. So that one's a little less obvious. You are probably going to have to remember that. Or if you don't remember it, it's in the back of your note packet. I stands for current. So you have this written there for you. I stands for the current. Now we measure the current in a unit called, and it's a word you've probably seen before, amps. Which again is just the the unit for this measurement that measures the amount of electricity moving through the circuit. Cool. And so that's our equation. And what this does, it'll let us actually solve for the current or voltage through a circuit. We'll try a couple together, 3 of them, and then you'll try a couple on your own. That'll be a good lesson. So we're working again with really just these two equations here, these two forms of Ohm's law. So the voltage supplied to a circuit with a resistance, we have a resistance of 100 ohms, is 25 volts. How much current will flow through the circuit? Well, we're solving for the current, which is I. So I equals V over R. And I know that's one we're using because, again, we're solving for the current, which is I. Okay, V is, V is the voltage. It's probably the number that's in volts, the 25. So it's 25 volts over, and I think the resistance is 100 ohms. So I'm just going to use that symbol that we mentioned before for ohms. Okay, 25 divided by 100 is, I think, 0.25, and current is measured in amps, which we abbreviate with a capital A. And that's it, 0.25 amps. Alright, cool. So we figured out how much electricity is moving through the circuit, and if we really took like a deep dive into circuits, we can use that to figure out how much charge is moving through it, how many electrons. We can do a lot with this value. For now, this is good. Alright, a current of 2 amperes, which is just the longer way of saying amps, flows through the circuit with a resistance of 10 ohms. What's the voltage supplied to the circuit? Alright, I'm saying, what is the voltage? So, out of these two, I'm going to jump down here now, which helps you solve for voltage. I would say this top one, the one that solved for V. V equals IR, which means I times R. Alright, I is 2, and we know that because it's the thing that's measured in amperes. R is the resistance measured in ohms, so that's the 10 ohms. Alright, well, it looks like we've got 2 times 10. 2 times 10 is, I believe, 20. And it says we're solving for the voltage, and so 20 volts with a V. There we go. 33, a 12-volt battery is connected to a device that has a resistance of 4 ohms. How much current flows through the device? Alright, we're solving for current again. Out of these two, I think the one that lets you solve for current is this top one right here. I equals V divided by R. I equals V divided by R. I think V is the 12 and the resistance is the 4. 12 divided by 4, I think that's 3. And we're solving for current, which is measured in amps. 3 amps. Cool. So again, it's just the 2 equations, so you're really just going to figure out which of these is the best fit for whatever it is you're solving for, and then do the appropriate math, either division or multiplication. So on your own, I want you to pause the video and try the rest of these questions. That's 34, 35, 36, and 37. Give them a shot. I'm going to give you a second to pause the video, try them, and then I'll go over. Calculate the voltage supplied to a device if 0.05 amps of current move through it. The device has a resistance of 1300 ohms. Alright, so what are we finding? Voltage. And I think the equation that solves for voltage is the V equals one. V equals I times R. I is 0.05 amps, and then R is 1300 ohms. We're going to multiply these two, because that's what the equation says to do. Multiply the two, and I got an answer of 65 volts. That's what I got when I put this in my calculator. There we go. Oops. Alright, 35. A 330 ohm resistor is connected to a 5-volt battery. How much current moves through the resistor? Alright, what am I solving for? How much current moves through it? So that is I. So I'm going to use the I equals V over R equation. V is the voltage, 5. R is the resistance, measured in ohms, 330. Okay, 5 divided by 330 gives you 0.015 amps. So that seems like a small number, but it turns out that an amp is actually an awful lot of current, so it would be probably like a dangerous amount. You don't typically see that. So normally you'll see like, some sort of decimal form, like 0.01 or 0.001 amps moving through a circuit. 36. In a flashlight, a battery provides a total of 3 volts to a bulb. If the flashlight bulb has an operating resistance of 5 ohms, how much current goes through the circuit? Again, the important part here is figuring out what I'm asking for. How much current is the question. So, as soon as you can recognize that, we're just going to do I equals V over R, the one that's solved for current. V is the one in volts, that's 3. And then R is the resistance, I think is 5. 3 over 5 is 0.6 amps. And again, a decimal is sort of a reasonable value for these currents, so that works. 37. If 0.5 ampere of current, so that's our current I, it moves through a 50 ohm resistor, how much voltage does the resistor use up? Alright, the question is, how much voltage? So let's solve for voltage using V equals I times R. I is 0.5, R is 50. Multiply these in your calculator very carefully. I think that 0.5 times 50 is 25. And it was voltage, which is measured in volts. There you go. So that's Ohm's law. That's our sort of math addition to circuit analysis. And that's it.